Hello everyone. Today I am going to discuss about combination of resistors. After watching this video, you can able to understand very easily what is the combination of resistors and how the currents and the voltages are distributed among the branches of the combinations. In various electrical circuit, we often use resistors in various combinations. We therefore optimize the circuit to see how Ohm's law can be applied to the effective combinations of the resistors. There are two methods of joining the resistors together. Number 1. Series combination. In this connection, the resistors are joined into each other like this, where R1, R2 and R3 are the individual resistances joined into each other. Thus, the current flowing through each resistors remains same. Current flowing through R1, R2, R3 are always same. Let us complete the circuit and switch it on. Here in this circuit, the current I is flowing through R1, R2 and R3. The potential difference across a combination of resistors in series is equal to the sum of the potential difference across the individual resistors. That is, V, the potential difference across the combinations, is equal to V1, the potential difference across R1, plus V2, the potential difference across R2, plus V3, the potential difference across R3. On applying Ohm's law, we can write V as a IR and V1 as IR1, V2 as IR2, V3 as IR3. I is common and we can write IR equal to I into R1 plus R2 plus R3. I is a common factor and we can strike it out. Or R equal to R1 plus R2 plus R3, where R is the equivalent resistance of the combinations and R1, R2, R3 are the individual resistances. Thus, the equivalent resistance of a circuit connected numbers of resistors in series is equal to the sum of the individual resistors, or R equal to R1 plus R2 plus R3, where R is the equivalent or effective resistance of the combinations and R1, R2 and R3 are the individual resistors that connected in the combinations. Now let us go through some example so that we can understand more easily how the currents and voltages are distributed among the branches of the combinations. Here in this example, an electric lamp having a resistance of 44 ohms is connected in series with a conductor of 4 ohms resistance to a 12 volt battery. Find A, the total resistance of the circuit, B, the current through the circuit, and C, the potential difference across the electric lamp and the conductor. Now let us draw the circuit. Here An electric lamp of 44 ohm is connected in series with a conductor of 4 ohm resistance to a battery of 12 volt battery. Now let's see what the question asked. A, R equal to what? What is the value of R? That is, R is the effective or the equivalent resistance of the combinations. V, I, the total current flowing through the circuit. C, V1, what is the value of V1? V1 is the potential difference across the electric lamp. And V2, V2 is the potential difference across the conductor. Resistance of the lamp and the conductor are given. R1 equal to 44 ohms and R2 equal to 4 ohms. Now the total resistance. Total resistance is given by the sum of the individual resistors. That is, R equal to R1 plus R2. We simply put the values here, 44 plus 4, which is equal to 48 ohms. 48 ohms is the total circuit resistance or the equivalent resistance of the circuit. We already calculated the value of R, and now we are going to calculate what is the value of I, the current flowing through the circuit. Current flowing through the circuit, V equal to IR or I equal to V upon R. We simply put the value here, V is 12 and R already we have calculated 48. So 12 upon 48 is 0.25 amperes. Now see the potential difference across electric lamp. V1 and V2, the potential difference across the conductor. Potential difference across the electric lamp, V1 is given by IR1. I is already calculated here, 0.25, and R1 is also given. We simply put the values here, 0.25 into 44, which is equal to 11 volt. 11 volt is the potential difference across the electric lamp. Now let us calculate V2. Again applying the same Ohm's law, V2 equal to IR2. I is already calculated and R2 is also given in the example. Simply put the value here, 0.25 amperes into 4 ohms, which is equal to 1 volt. From this example, we come to understand that the potential difference across the combination of the resistors in series is equal to the sum of the potential difference across the individual resistances. That is 11 volt, and 1 volt is the potential difference across the individual resistances, and the sum of this is given as 12 volt, the total potential difference across the combinations. Thank you for watching the video. Please don't forget to subscribe it and press the bell icon.